An angle that measures 90 degrees is called the right angle. An angle that's less than 90 degrees is called an acute angle. An angle that's more than 90 degrees is called an obtuse angle. An angle that's 180 degrees is called a straight angle. When two angles add up to 180 degrees, they're called supplementary angles. When two angles add up to 90 degrees, they're called complementary angles. When two lines intersect, all four angles add up to 360 degrees. Two side-by-side angles called adjacent angles add up to 180 degrees. Opposite angles are equal, and you know the degrees of any one angle. You will be able to calculate the degrees of the other three angles.
Well, welcome back, geometry students. This is our last lesson in chapter 1.6. And the big ideas, we're describing pairs of angles in this lesson. And like the song was just talking about, we're going to learn about complementary, supplementary angles in this lesson, as well as linear pairs and vertical angles. They call them adjacent and opposite angles, but we're also going to be seeing that they're also called linear pair for adjacent angles and vertical angles for opposite angles. Now, before we get into that, let's go ahead and look at a cartoon. So in the bleachers here, out on the baseball field, the ump's got this little device, little shot collar on the, I guess, a coach there. And when I repeatedly activate the shot collar, he learns that arguing with the ump will not be tolerated. He keeps zapping the guy. Yeah. All right, well, let's go into our lesson for today. On page 29, you'll see some vocabulary there, but they're all written in the core concept on this one. So you just need to highlight core concepts for your vocabulary, and starting with the complementary and supplementary angles. That's what we see there. And so complementary angles mean, as you can see, adding up to 90 degrees. So you have the word complementary, or you could also talk about complement. So each angle is the complement of the other because they add up to 90 degrees. If they have a 20-degree angle and a 70-degree angle, they are complements of each other because they add up to 90. So they could be on the same angle, which this would be adjacent angles. So you got adjacent angles right here where they're kind of right next to each other. This one would be, they're not adjacent. They're two separate angles. They could still be complementary, but they're two separate ones. So with these two adjacent angles right here, and they add up to 90, that's definitely complementary. Here's another situation with supplementary. Again, we have adjacent angles when they're on the same line here, or they're using the same ray. Same thing here, they're going to use the same ray. You got 90-degree angle here, but you got a ray through it, so that's adjacent. You got the 180 degrees here with the straight angle, but then you have a ray through this, so these 3 and 4 are adjacent. Angle C, angle D are not adjacent. They're two separate angles, but they still can be supplementary if they add up to 180 degrees. You could definitely see 3 and 4 add up to 180 because it's a straight line. Straight angles are always 180. And again, you can also call it the supplement. So 65 is the supplement of 115 because they add up to 180. Adjacent angles, and that's what I was just talking about. There's the word adjacent angles. They're the ones that have this common side. So that's why this right here were adjacent because they had a common side, and here 3 and 4 are adjacent because they have a common side. So they have a common side and a common vertex is what makes adjacent angles. Angle 7, angle 8 are non-adjacent. Just like I was saying, these are non-adjacents here, the 20 and the 70, 115, 65. They're like these. Not the same, they're not together. So they're two separate angles. And when they are together like this, sharing a common side, sharing a common vertex, they would be considered adjacent angles. Okay, so here's going to be a couple examples, and you don't need to write these down, just watch them. It says, in the figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So as far as the complementary angles, they'd have to add up to 90. So 37 plus 53, that would add up to 90. So these two angles here, and we would name them. Remember, the vertex has got to be in the middle. So RST on that one, BAC on this one. So that's going to be these two, angle BAC, angle RST. Those are complementary. Supplementary, they have to add up to 180. So that's going to be 127 plus 53 is 180. So RST again with CAD on that one. So angle CAD and RST, those are supplementary. And then the adjacent pair, so a pair of adjacent angles, that's going to be where they have a common side and a common vertex. That's these two guys right here. So CAD and BAC. Those are the two that share the common vertex and side. So they're adjacent angles. This next example here is, and again, just watch this one as we look at it. So A says that angle 1 is a complement of angle 2. And it tells us that the measure of angle 1 is 62 degrees. Find the measure of angle 2. So it says here to draw a diagram, and you don't have to draw a diagram because if you know that it says complement, you know that means they add up to 90. You could just say 90 minus 62, and that's what would give you 28 degrees for measure of angle 2. This one says angle 3 is a supplement of angle 4, and 4 is 47 degrees, so find the measure of 3. And for this one, supplement means 180 degrees. They add up to 180. And so you could just say 180 minus 47. You don't have to draw the diagram. You can if you want to. But it'd just be 180 minus 47. That would be 133 degrees for the measure of angle 3. All right, let's go on to our extra practice. Okay, so for the extra practice 1 and 2, you're going to use the figures there on the right. It just says for number 1, name a pair or pairs of adjacent complementary angles. So there might be one of them, there might be two of them. Take a look at the diagrams and see if you can find at least one pair, there's at least one, adjacent complementary angles. See if you can think about that. I'll give you a second to take a look. So if you're looking for something that's going to add up to 90 degrees, you're seeing over here on this side 15 plus 75, that does equal 90. So these are adjacent because they do share this common ray and this common vertex. So they're adjacent and they're complementary. So that would be these two right here. So you can name it as, here's our answer for this, what you would write down here on number 1, angle TOS, which TOS is the 15 degree angle right there, TOS, and angle TOP, that's the 75 degree angle right there. Then number 2 says name the pair or pairs of non-adjacent supplementary angles. These ones are not going to be next to each other. They will not share a common side or vertex, but they do need to be supplementary. They need to add up to 180. So I'll give you a moment to take a look and see if you can find them. Okay, so you're looking at ones that are going to be non-adjacent. So you can use maybe an angle over here like 105. 105 plus 75 would be 180 degrees. So you could use this LJM angle with the TOP. That would work. So that's going to be one of our answers. The LJM and TOP, those two angles. Also LJM with this other angle here at 75 degrees. That's the QOR angle. So there's two of them on this one. Then for number 3 and 4, it does say find the measure of the angle. So 3 says the angle A is a complement of B, and the measure of angle A is 36 degrees. Find the measure of B. 4 says that C is a supplement of D, and measure of D is 117. Find the measure of angle C. So I'm going to have you try these on your own, just like I was showing you earlier. Just go ahead and subtract from 90 or 180, depending on which one it says, and that should give you your answer. Go ahead and pause the video, do 3 and 4, and then play it again to see if you're correct. All right, hopefully you paused it. You got the answers for 3 and 4. Let's go ahead and check these. So for this one, complement means 90 degrees. They add up to 90. So 90 minus the 36 degrees there. 90 minus 36 is going to give us 54. So our answer is going to be 54 degrees. Measure of angle B equals 54 degrees. Supplement means they add up to 180. So 180, we're going to subtract 180 minus 117, and so that's going to give us a 63-degree angle for the measure of angle C. So we'll write it down like that. Measure of angle C is a 63-degree angle. Now, sometimes my angles look kind of like inequality symbols, but it's supposed to be an angle there. All right, moving on to our next part. All right, so in problem 5 and 6, it says find the measure of each angle. And so that would be, well, obviously we can know the measure of the big angle right here. It shows us it's 90 degrees. We don't have to find the measure of BAD. What we want to find the measure of is inside here on each of these sides where the expressions are. So if this is a 90-degree angle, these are going to add up to 90 degrees. They are complementary, so they're going to add up to 90. You can see it's a 90-degree angle there. So we're going to take the expression starting with 10x plus 22 and add it to 7x plus 34, and it's going to equal 90 degrees. So these two expressions, it's just angle addition, and we've done that already. So you just add these two up, and it's 90 degrees. It's always going to equal usually 90 or 180 in this lesson because we're talking about complementary and supplementary angles. So as we solve this, we're going to first combine like terms. So we're going to get 17x, and then 22 plus 34 gives us 56. So 17x plus 56 equals 90. Subtract the 56 from both sides. We're solving this. You guys should be able to do this on your own. So again, you're just setting up your equation most of the time to find x, and then we got to plug x back into here. And so once you get your x, then when you subtract, that's 17x equals 34. So divide by 17, and x is going to equal 2. So now what we need to do to find the measure of each angle is plug 2 in for x in both expressions here. So 10 times 2 plus 22. That'll be our first one. So that's 20 plus 22, so that angle is 42. So the measure of angle BAC, and that's what you want to say as an answer, measure of angle. Use the M for measure, angle BAC, name it correctly, and then that's 42 degrees. Make sure you put the degree symbol. And then do the same thing for this angle, 7 times 2 plus the 34. So plug the 2 in for that. So it's 14 plus 34. And you add those together and you get 48 degrees. So the measure of angle DAC equals 48 degrees. All right, so I want you to try number 6. Number 6 is the same thing, except in this case, instead of 90 degrees, like here, it's a straight angle, which is 180. These are supplementary. So you're just going to set your equation up at, where this one, top one's going to add to this one, and it's going to equal 180. Go ahead and solve for x and then find each one. So pause the video and complete number 6, and then check it once you're finished. Okay, hopefully you've got number 6 complete now, and you set up the equation this way, where you start with the 6x minus 5. You could start with the other one, it doesn't matter, but they're going to add to each other. So plus the 12x plus 5, and it's going to equal 180 because it's a straight angle here. They are supplementary angles, adjacent supplementary angles, in fact. These are adjacent complementary. So now just you're combining like terms. So it's going to get you 18x because the 5's will cancel out. So just 18x equals 180. Divide by the 18, and that's going to be exactly 10. X equals 10. So now you know the number to plug in for x. So this top one's going to be 6 times 10 minus 5. So that's 60 minus 5, which is 55 degrees. So the measure of EFH, of angle EFH, is 55 degrees. Now at that point, okay, here's where you could figure this out, that at that point you don't need to plug in 10 to this expression. If you know this is 55 degrees, you could now just do 180 minus 55 and figure out this angle here. We could have done the same thing over here. Once I knew this was 42, I could have then done 90 minus 42 and I would have gotten 48 degrees. So you're just trying to figure out the measure of each angle. So you don't have to plug it back in for the second time, but you do need to do it at least once. Now I am showing and doing it on this other one as well. So 12 times 10 is 120. So that's a 125 when we add the 5 in there. So the measure of angle GFH is 125 degrees. They do add up to 180. So here we'll pause a little for a joke of the day. So why won't the baby oyster give up her pearl? Because she was a little shellfish. That's always a good one. All right, so on page 30, our core concept here has linear pairs and vertical angles. So on that beginning video song, they were calling these adjacent angles and opposite angles. I don't usually like that so much because, adjacent angles can be, adjacent and complementary, adjacent and supplementary. A linear pair, however, is adjacent angles that are always supplementary. That's what it really is. So what a linear pair is, and again, highlight for your vocabulary. So the linear pair is two adjacent angles, so there has to be adjacent angles to be a linear pair. When their non-common sides are opposite rays, so that has to be supplementary then. Their angles the angles in a linear pair are supplementary angles. So they're adjacent supplementary, basically, is a linear pair. The vertical angles are the ones that they were calling opposite angles. So that's basically like 3 and 6. Those are going to be equal or congruent. We can call them congruent or equal. Their measures are going to be equal. 4 and 5 are opposite of each other, and so they're vertical angles, and so they're going to be always congruent. So it says two angles are vertical angles when their sides form two pairs of opposite rays. So basically what you're seeing here is almost like kind of an X in here. They all would add up to 360 if that's the case, like that. But you could have maybe a vertical angle some other way. Usually you're going to just see it as an X, though, on there. And so the vertical angles always show a kind of a V shape. A V shape here, a V shape here, and they're exactly the same thing. They're congruent. So they have to be opposite rays. So that's going to be opposite ray there, an opposite ray here as well. So those are definitely forming kind of an X shape. So here's another one that you can just watch this, and you don't need to write this one down. It says identify all the linear pairs and all the vertical angles in the figure. Now the figure has several lines going through it. So as far as to find vertical angles, let's look at that one first. That would definitely be where you need to see like an X in here. So if you look at this straight line here and this line going straight this way, that forms kind of an X shape. So angle 1 and angle 5 would be vertical angles. They're got the opposite rays there going. And so that's what 1 and 5 are vertical angles. So you definitely got a V there and a V there that are going to be opposite of each other. And then to find the linear pairs, you're looking for adjacent angles. And so basically a linear pair is going to be adjacent angles. So 1 and 4 are adjacent, and they also have to add up to 180. So 1 and 4 has got to have a straight line here where 1's going through it. So that's going to be 180 degrees. So 1 and 4 are adjacent angles. 4 and 5 also have that same thing going with this line going through here. So 4 and 5 are also a linear pair. So you can't say that 2 and 3 are a linear pair. They are adjacent, but they're not a linear pair. 1 and 2 are not a linear pair. They are adjacent as well, but they're not a linear pair. All right, so back to our extra practice. This is on page 31. Number 7, and we're using this figure here. 7 says identify the linear pairs that include angle 1. So angle 1 is here. What are the linear pairs that would include that? So look at that diagram. See if you can think of, it's going to be 1 with what other number would form a linear pair. See if you can figure this out before I show you the answer. Okay, remember that it's got to have to be supplementary. They have to be adjacent and supplementary. So what's adjacent to 1? Well, 2 is adjacent to 1. Are they supplementary? Yes. So 1 and 2 are a linear pair. 4 is also adjacent to 1. Are they supplementary? Yes. So both of those are going to be your linear pairs. Angle 1 and 2, angle 1 and 4. Then in number 8 says identify the vertical angles, which would be all the vertical angles in this whole entire figure. So right up here, you can definitely see some ones fairly easily because you just got this X. 1 and 3 definitely are vertical. 2 and 4 are definitely vertical. But when you look down here, see if you can find some vertical angles down here. So take a look at these numbers and see which numbers you might think are vertical down there. So again, you're looking for them to be kind of forming an X. So if you look at this straight line going through here, and maybe this line right here going across, you can see, well, there's 9 and 6, okay? And with this line going down and that line, you have 5 and 8. And here with these lines right here going straight across, you have 10 and 7. So a whole bunch of vertical angles are in there. And you just want to write them all down. So we already said from up on top here, there was 1 and 3, angle 2 and angle 4. That was up here. And then we said 5 and 8. Those are vertical angles. 6 and 9. Those are vertical angles as well, because you could see the opposite rays going there. 7 and 10. Those are also vertical angles. So you can see obviously like 6 and 8 are not going to be vertical angles. Even though they come and share that common vertex right there, they're not vertical angles because they're not a pair of opposite rays. Even though they have this one that's opposite rays here, this one here is not an opposite ray, the other two sides. So the sides, all the sides have to be opposite rays of each other. So that's why when you see like an X, like straight across vertical and horizontal, those are opposite rays that way, opposite rays this way. Number 9 says, are angle 6 and angle 7 a linear pair? So we're looking at 6 and 7 here. Are they a linear pair? So the answer would be yes or no here, but it says explain, why or why not. So think about that for a minute. See if you can think about if it's a yes or no, what you think, and think if you can figure out why or why not. Okay, so the answer for this, is it a linear pair? The answer is no, these are not. 6 and 7 are not a linear pair. And the reason why, and this is what you would say for the explaining, is because these are not supplementary angles. Right? A linear pair has to be both adjacent and supplementary. So for this one, it says no, the non-common sides are not opposite rays. So that's kind of more of a technical way. You could say it that way. But I just think of it as it's got to be adjacent and supplementary to be a linear pair. And you can write that down like I said. It needs to be, it's not supplementary. They are adjacent, but they're not supplementary. All right, I know we're done with the extra practice at this point, but there's a couple more problems I want us to write down in the notes. So go back into our notes a little bit, back a couple pages, and we're going to do a couple more problems there. Okay, so for this one, go back to page 30, and the notes section at the bottom of that page, we're going to do this one. It says, and write this down, write the problem down because you need to know this. You want to see this in your notes. 2 angles form a linear pair. The measure of one angle is 5 times the measure of the other angle. Find the measure of each angle. So here we need to actually figure out, okay, we're going to have to write an equation that would work for this. Now, if you know it's a linear pair, you know they would be supplementary. They're going to add up to 180 degrees. So you could draw a diagram like that, and you're going to now need to kind of mark this down because it says the measure of one angle is 5 times the measure of the other. So one of the angles you would want to write as just x, and the other one would be 5 times x. So there's your 2 angles in expression form. So we would know that since they are going to be supplementary, they're going to add up to 180 because it says it's a linear pair. And so we made the diagram look like it's they're adjacent and they're supplementary. So now we could just say 5x times, or 5x plus x, add those two together, and it's going to equal 180. So that's what we'll make our equation out of. So write this down there on your paper. X plus 5x equals 180. You can put the degree symbols there too. And then just solve. So this is going to be 6x equals 180. Divide by 6, and we get 30. So x equals 30. So one of the angles is 30 degrees. The other one is 5 times 30, which is 150 degrees. There's the measure of both angles. So the measure of the angles are 30 degrees and 150 degrees. So just make sure you write down the measure of each angle there on that one. All right, let's do one more problem and then we'll be done with our lesson. All right, so this is going to go on the notes on the bottom of page 29. So go back a page to page 29, at the very bottom section of those notes. I think it's underneath the supplementary, complementary, core concept to put this example here. So it's got a soccer player. It says, when viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. Find measure of angle BCE and the measure of angle ECD. So those are marked off with these expressions. So ECD is this expression, x plus 2, and BCE is 4x plus 8. So I want you to pause the video and then set up your equation. Set your equation up for this one, how you would solve this. And set the equation up, and then I'll show you if your equation is correct. So pause it, and then write your equation down, and then start it again. Okay, hopefully you do have your equation down at this point. Let's go ahead and look and see what your equation should say. So your equation should look like this, where you're going to add these two up, and it's going to equal 180. So 4x plus 8 plus the x plus 2 is going to equal 180. Now you can have those, you can have the x plus 2 first if you want, and the 4x plus 8 second, that's okay. But that should be your equation. So now go ahead and solve this equation, find out the answer for x, and then so pause the video, solve it, and once you know what x equals, then start it again to see if your answer is correct for x. Okay, so hopefully you've got an answer for x now. We're going to combine like terms, so it's going to be 5x plus 10, subtract 10, so it's 5x minus, or is going to equal 170, x would equal 34. So 5x, or I guess you divide by 5, so 170 when we subtract here, divided by 5 is 34. So you should have got x equals 34. Now what you need to do to find the measure of each of these angles is plug 34 back in, and we did that earlier. So go ahead and do that, and then play it one more time to see if you're correct. So find each of these angles, the actual degree measure for each one. Okay, hopefully you plug 34 into like 4x plus 8, so 4 times 34 plus the 8 there on that one. And so that's what they're doing here. That's 144 degrees for that angle. And then over here, 34 plus 2, that's just 36 degrees for that angle. So that's what you needed to find on this one. So that concludes our lesson now on 1.6. You're ready to do the assignment for 1.6, and I'll see you in Chapter 2.